Hello guys, welcome you all for this end-to-end session on AIML. Hope you guys are enjoying. So this session is all about a year session where you guys gonna learn everything that you guys need to in order to become a successful data scientist from a scratch. Where you guys gonna look into what are the fundamentals of data, how machine learning works, how AI works, how deep learning works. This everything you guys gonna learn. So we are very enthusiastic and very happy. Like we are launching this kind of course. Actually, we have completed nearly 50 plus days. Okay, so where we have covered lots of things like everything related to data we have completed, and then we have stepped up into machine learning, where we have started with the theoretical concept like their types, and we have gone through a coding session like a linear regression session, and today we're gonna have our next coding session like this is for multiple linear regression. Guys, as always, make sure you guys have watched all the previous session videos so that you can have a better understanding. For me, for now, you guys should have watched the previous session, because like previous session is all about the theoretical concept of multiple linear regression. Today we're gonna see the coding part. Okay, hope you guys are enjoying. So we are enjoying a lot, and we are learning every day, guys. Believe or not, we are learning every day. So sir also will just because like whenever we are just taking a session, like we are just researching, and we are just able to get whatever the things right. Okay, we are just make it up, and then we are just saying you guys. Okay, so we are very happy. So without wasting any time, just we will go into today's session. Today's session is a coding part of multiple linear regression. Okay, hope you guys have already know about it. So I will say, if you guys have watched previous session video, then you guys know what is multiple linear regression. Whenever I say multiple linear regression, you guys should have this in mind. Okay, let's see how many of them know it. Please put it in the comment section, guys. What is multiple linear regression? Okay, I will give a minute time. Okay, let's have a let's reduce the time. Let's have 10 seconds. Okay, so because like it's gonna be very simple. Okay, so let's see how many of them getting correct. Okay, so yeah, so linear regression means y is equal to mx plus c, right? That's right. Okay, what then multiple linear regression means simple. Y is equal to m1 x1 plus m2 x2 plus m3 x3 plus dot 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 2 mn xn. Okay, plus c. That's it. Okay, we're gonna have multiple independent variable using which we're gonna predict the dependent variable. That's the only thing. Okay, yeah, we will jump into today's coding session. So guys, I hope like if you guys are continuously watching our video, you guys already know what it is. It is a collab. Okay, it is provided by Google, so it is an online platform which has lots of I will say enormous number of advantages, guys. Everything about it, how to install it, how to set up it, everything is teach to you in the like I think first session of coding. So we have just elaborated everything about it. So hope you guys have watched those videos. We just directly jump into the concepts in this coding. Okay, multiple linear regression. First step, guys, I'm gonna import the necessary libraries. Okay, pandas. I hope like if you guys again, I'm just saying why I am again saying is like you guys need to watch all our sessions so that you can have a flow and you can have a continuation. Okay, pandas, which is used to perform different kind of mathematical, I will say not a mathematical, like data frame related operation. This numpy is used to perform all kind of mathematical operations, whereas this matplotlib used for visualization kind of thing. Seaborn is also is a visualization kind of thing. It's a tool which is built on top of matplotlib, and we are having model solution where we will be using train test split. That is where, and then from sklearn I'm going to import the linear regression model. Okay, and then we are having one more thing, metrics, which is used to calculate how much accurate your model is predicting. Okay, using mean squared error and then R to score. Okay, now you guys will have a doubt, right? Where is multiple linear regression? Right, you guys will be having a doubt. Okay, we have already explained you, it's an extension of linear regression. That's it, right? So I have a linear regression in place. I will show once code progress. Okay, you guys can see. Okay, so I will say if we are having one independent variable to predict the value of the dependent variable, then we go for a linear regression. If we have two or more independent variable to predict the value of the dependent variable, then we need to go for multiple linear regression. That is what a theoretical concept says. But for coding, we are having only one thing. Okay, so linear regression is a formula for y is equal to mx plus c. If we are having more x, then internally the code will also work. You guys gonna see. I'm not going to base it up like this is a similar like linear regression, but we will be having two independent variables. That's it. Not a magic I'm going to do. Okay. Moving on, let's see this you guys already know. I'm just creating a data set for it. So first thing, I'm just setting the seed, which is whenever anyone in the world run this code, right, they're gonna have a same kind of data set. Okay, that's the reason I'm just setting the seed. X1 and X2. So X1 is the first feature. Okay, I'm just creating randomly 100 values, and the 100 value will be multiplied by 100. Then I'm just X2, I'm just creating a 100 value which is multiplied by the 50. Okay, and my Y is something I'm just giving manipulating 3 plus 2 into X1 plus 1.5 into X2, and then I'm randomly creating 100 values into 10. That is what target value. Guys, you guys see here, right? We are having two x1 and x2. That means two independent variable. And y is the only dependent variable. You guys say me, what is the formula? Simple, right? Y is equal to m1 x1 plus m2 x2 plus c. That's it. Okay, because we are having two independent variable. Okay, guys, hope like this is very easier for you. Okay, right? So moving on, we are just creating a data frame out of it. We have feature one, that is x1, feature 2 is x2, and our target is y. Guys, just see here. That's it. This is what the data set that we are having. If it is a linear regression, we will be having only one feature and then the target. Since it's a multiple linear regression, we are having two features and then a target. Okay, guys, I hope like you guys are understanding, right? We have created a data set. Okay, so hope till this step everything is clear. So I'm just not at all loading the data set. I'm just creating a data set for you guys to understand from a scratch. Okay, then I'm going to summarize this data set. First is data.describe. So data is like a variable name which is given to this data frame. That is our data set. Okay. When I'm going for a describe, it's going to describe our data set. See here, guys. First is count. We are having 100 counts for all the columns. What does it mean? For feature 1, it is 47. For feature 2 it is 26. And for target value, it is 136. Like that, we are having standard deviation, mean value, 25%, 50%, 75%, and then we are having max value. Okay. Then I'm just printing the head of it so that we will see only 5 values. If you print try, it will give the last 5 values. That's it. Okay. Just see here, guys. We are just printing the top, I will say top 5 values, head of it. Okay. So hope you guys have understand this. Okay, there is no rocket science, I have said that, because like it's a simple thing, guys, because like I have just imported the necessary libraries, then I have just created data set for you guys, and we have just created in the form of a data frame, and I have summarized it. Okay, so these are the things, these are the three things I have just done. Okay, now moving on, we are going for a pre-processing the data set. It's a simple. Okay, I'm going to check whether the data set is having null value or not. Okay, how to do it? We are having data, right? That's the name of the data set, right? Then is null is a function which is used to deliberate what are the null values, how many null values present, okay, in each and every column, and then I'm just summing it up. You guys see the result here. Feature 1, there is no null value, so 0. Feature 2, there is no null value, that is also 0. And feature 3, there is no null value. Sorry, target value, there is no null value. So our data set is very clean, guys. Okay, and the data type is int. Okay, you guys tell me, is the data set is ready for us to go for the uh, model? It's ready, right? Because it doesn't have any null values and it is also integer type. Okay, hope everything is right. Okay, so I'm just going for again the flow. We have imported the necessary libraries, we have created our data set, and we have moved on to summarizing our data set. Finally we are going with the pre-processing the data set. Okay, so this is what all about it. So let me hand over this to sir, so sir can also explain a little bit more. Yes sir, over to you.
Yeah, so here we are going to apply this. Guys, if you have come to this session, so go and watch all the sessions 5 to 10 times and absorb the information, digest the information, and apply. So here we are applying, and subscribe to our channels, or also press the bell icon so that you will get notification for each session. So keep learning deeply with persistency, patience, and consistency, and perseverance. So have a long-term objective for your career, and write in the comment section what have you learned, what is the objective function of your long-term career, and write in the comment section, give us feedback. We can improve each session for you guys. So continuous improvement is the key. So let us start multiple linear regression. So first step is we'll import necessary libraries. So we are importing pandas, numpy, matplotlib, okay, seaborn, sklearn, and sklearn for linear model, linear regression, train, test, and split. Where we also are loading sklearn matrix, import mean, like mean squared error for error detection and all. So then we are going for step 2, loading the dataset, generating synthetic dataset with np numpy.random.seed. Okay, we are using this x and y variable we have, and for that we have given the features, feature 1 and feature 2, and our range is 100 multiplied by 100, 100 multiplied by 50. Okay, then we have y is, we have defined y 3 plus 2 into x1 plus 1.5 x2 variable plus np dot random. So we are giving this as a target variable so that we can our x and y variables will be with feature 1 and 2. They will start doing this, start working on it, and we have given target variable according to that. So then we are creating the data frame. We'll create with data equal to pd dot data frame feature 1 x1, which is our variable 1, and feature 2 x2 and target y. So that is our target variable, and that's y. And then we have, see, now we have a data which is the output based on feature 1, feature 2, and target. So these are the target variable, and these are the features. Okay, so we have this, and we have 100 rows into 3 columns. Okay, so data is very simple. You can see 3 columns and it is into 100 rows. Okay, so this is how, but we have just printed the few rows so you can see, but you can have a feel and look for this data. Okay, let's go to the, yeah, that's it, or we are going for summarizing, right? We have taken this,
Yeah,
Raja, this step, or
yeah, sir. Summarizing. Yeah.
yeah. So summarizing the data set, here we see summarizing. We simply write print data dot describe, okay, brackets, and print data dot head. So it will describe, it will show the head of it, and you can also see tail of it. Okay, so how it looks like. So like you said, print dot head, data dot head, you can write print data dot tail also. Okay, so that you can see the tail of it. And then you have feature 1, feature 2, and target value. Okay, so you have a look and feel, and you can see your data, how it looks like, what is the standard deviation, what is the mean, what is the max. Okay, what are different quartile percentiles. So on different percentiles, how data looks. So you will see the behavior of data, how it feels, how it looks, and you can drive inference out of it. Let's move to the fourth step. So here we have pre-processing the data. We'll pre-process. So we'll check null values, guys, because we've been discussing a lot pre-processing, how to check missing value, how to check null value, how to check outliers, how to check anomalies. So here we'll see, and we are checking null values. We feature 1, feature 2, target value, we have none, and yeah, that this is how we can check. You can check missing values, you can check outliers, you can check anything what, okay, when you're doing pre-processing related to pre-processing. Step 5, yeah, there we have feature 1, feature 2, which will show the output, and then we have segregating data into input and output. So we have a variable x equal to data, y, we have already defined it. If you see, when we started, we defined x and y. So then feature 1 is also defined, feature 2 is also defined, and target is also. So then it will segregate feature 1 and feature 2 because they are already defined. And guys, you have to define everything in computer programming, okay? Until and unless it is supercomputer, I think still we have to do some pre-processing and we have to define things, what it means. So then and only you will get that kind of. So computer doesn't have consciousness. You have to give consciousness to computers, give logics, and define each and everything, even comma. If you suppose if in the Python they have defined comma for a specific function, guys, you have to use it for specific function, otherwise you will have error. So everything is defined as an architect, but in that architect you have to work within that framework, you have to work. Okay, so this is the feature 1, feature 2. This is how it feels and looks, and we can see that 100 rows, 2 columns. Okay, let's go down. Then we have target value, target variable. Target variable is from 100 rows, 1 column. We have seen, we have defined till 100, so we have this. Then we see the shape of data, right? So the shape is like 100 to 100. Okay, so we have given okay, so this is the shape of X shape and Y shape. Okay, then we have step 6, splitting the data into target and testing data. So we have covered this till now or not?
Oh,
Step.
sir, we have just completed step 5 from here.
Yeah, so you can
Yeah,
start
sure, sir.
that. So I've gone a little bit far. Yeah, I
No,
think.
no problem, sir.
Yeah, so then not a problem.
So,
So you can start, yeah, and then I'll
yeah,
give a summary, a simplistic view, simplifying
yeah,
each and everything. Yeah, let's start
sure, sir.
uh,
Yeah, sure, sir.
next step. Yeah.
Yeah. So yeah, sir has like given some important steps how to do that. So till pre-processing we have done, guys. Okay. Next we are going for segregating the data set input and output. As sir is mentioning, right? Computers does not know what it is. Okay. We need to say this is the input, this is the output, have it and then work on it. Okay. As a human being, we know for a human being itself, it is very difficult for us to tell something. These are going to be our input and this is going to be our output. So how computers can do? So that's the thing. We need to specify for a computer this is the input and this is the output. Okay, so that's the next step. Segregating the data set into input and output. As I have specified, right? Our two features are our input. That's it. That is what X. That is our input. And what is our Y? Target is our Y. Finished, right? So X, you can see we will be having in a data set three rows, three columns, right? Now, first two column, that is feature one and feature two, or our input column, and the last column target is our output column. Input column, guys, feature one, feature two, and then our output column, it's a target column, Y. That's it. Okay. Moving on, we're gonna just print the shape as I always mentioned. X is our input, so we will be having two features, right? So that's it. Okay. When for Y, it is output. We are having single only one column, so it is 100 comma nothing means it's there is only one. Okay. Okay, guys, I hope like you guys know how to interpret it, right? So 100 comma 2 means 100 rows, 2 columns. 100 comma nothing means 100 rows, so there will be one column. Guys, can you able to understand? Because see here, guys, we are having 100 rows, that means we are having one column. Okay, that's the reason there is no 100 comma 1 also it's same, 100 comma nothing is also same. Okay, next, splitting the data set into train and test. Guys, this is a major thing. You need to split your data into training and testing part, so that when you train the model, you just need to give the training data, while testing you need to give the unseen data. The data which gonna be splitted from training is used as a unseen data. We are just learning in every session, right? How we can test a model? We can test a model only when it is able to predict the unseen data, right? I hope like you guys have remembered that. Okay, so it's simple. Train test split. Within that, I need to give what is my input and what is my output and my test size, 20% for my testing. And random state you need to specify 0. Like set seed, it is also 0. Like set seed concept. So whenever anyone who just run this notebook, right, they're gonna get the same out. So guys, see here now, X train, X test, Y train, Y trace. For training, we are having 80 data. That means from 100, we are just having 80. And for testing, we are having 20. Okay. So 80-20 split. That is 20% of data for testing and other things for training. Okay. Hope you guys have understand this. Next. We're going to load the model. Simple. Okay. We are linear regression model. That's it. And I'm going to pass the for how to train it. So because like the variable name for linear regression is model. Model.fit. That is how we can train the model, right? Model.fit. What is my input? X train. What is my output? Y train. That's it. Okay. X train will have two features. Okay. For linear regression, there is only one feature. So for multiple linear regression, we are having two features. That's it. And Y train. We have just trained it. Once we trained it, we need to predict, right? Model.predict. What is our X test, which is unseen by our model, and Y pred is the values which is predicted by our model. Okay, guys, see here, these are the results that is predicted by our model. Y pred is the result predicted our trained model, our model. Okay, now I'm gonna just see how our model works based on this thing, like using metrics. Auto score, within that I need to pass Y test is a value present in the data set. Okay. Y pred is a value which is predicted by our model, which we have trained using our training data. Okay. And this is what auto, which has the value for the auto score. That's it. It's kind of accuracy. Guys, see here, what is the accuracy? 0.9821. That means it has a 98% of accuracy. Just multiply it by 100. That's it. So we have a good model. Okay. Next. So I'm gonna predict a single output by using the using our model. You know the function, right? Model.predict is used to find the value. Within that, you need to specify the sample. Single sample. What is the sample I'm just specifying means? For first feature, I have given 50, right? Second feature is 25. And I'm just converting to an array because models can understand only array because we have trained our model in that form only. You just see here, this is the kind of data frame which will be used by the model as an array. Okay, that's the reason when I'm just predicting a single sample, this 50 comma 25, feature 1 is 50 and feature 2 is 25. I'm just having this numpy array, converting this list value to numpy array. Guys, still this it's list, right? Yeah, within square brackets. I'm just converting it to a numpy array using the function called np.array. Guys, hope it is very clear for you guys. Okay, single sample, I'm just passing it and it's gonna predict the result. So guys, see here, predicted output for a single sample 50 comma 25, that's 50 for feature 1, 52 25 for feature 2. We are getting 140. Okay, 140.1566 something. Okay, that's the target value we are getting based on our model. Okay, simple guys, there is no rocket science. Okay, very simple. If you guys are specifying this is my input, this is my output, and everything else will be taken care of model. Okay, it can load the model, we just need to specify our input and output, we train it, we just predict it, and we will just calculate the metrics, and then we can go for the single prediction. Okay, I don't like whether it is going to be very complicated or not, but like I hope like this is very simple. Okay, that is just 11 to 12 steps you guys need to follow for all the machine learning algorithms. Every algorithm is going to be same. Okay, only thing you guys need to pay attention is the theoretical part. That is where the black box comes. Do you guys think that these things cannot be done by people who is outside data science? No, right? Anyone can do this, but only thing that we can do is that we have a strong theoretical understanding which is called as a black box of each and every algorithm. Okay, that is what the uniqueness for us when compared to others. Okay, that is where we stand out when compared to others. Okay, so hope you guys have understand this. So I will just hand over to sir. So sir will have some more things to say. So I will just hand over to sir. Yes sir, over to you. I will just move up.
Yeah. So, guys, understand, absorb the information, digest the information, and apply. So each and every aspect of DA is so crucial that you cannot move from A to D to A, means apply until unless you don't absorb information without bias and completely, you cannot digest it. And like it's like food, nutritious food. If you don't eat nutritious food, you will not have, and you don't absorb it, you don't have healthy body, and then you will not have healthy life. Similarly, when you learn any concept, irrespective of data science or AIML or anything, until unless you absorb the concept so deeply at meta level, deep meta level, you cannot digest that properly. And then once you don't digest, you will not go and apply that concept properly. You don't know. You will do half cooked, like suppose you don't know how to cook a food, a recipe. So you will say, suppose you cook it half cooked and then you try to eat it. You will fall sick and then you will end up going to hospital, right? Similarly, when you don't absorb the concept properly, you don't digest that properly, and then you will not be able to apply. People start jumping into tools. Oh, I want to use this AI tool, that tool, this thing, that thing. Guys, you that is only 10%. 90% is absorbing the information and digesting the information. Applying is only 10%. What you will apply if you don't know? You will make a lot of mistakes, and you conceptual when you are not clear, even if you apply well, but your concepts are not clear, and you go for interview or you go for any, you discuss, people will say you've just you're not completely learned the skill end to end. So that is the problem. We always try to jump. We don't remain in present moment. We want to jump from one thing to another thing. But we don't stay still and absorb it as it is and then digest and then apply. That is why go watch all the sessions 5 to 10 times. Build persistency, consistency, and keep learning deeply with long-term objective function of your career. Okay, let us move to this. So splitting is very important, guys, because we have to split. And what is the logic behind splitting, guys? Because we have to do training, we have to do testing. That is the only logic for splitting data set. Otherwise, no. And we need to have verify. See, in data science or AIML, we do uh, a verified and like data driven decisions. We don't do random decisions. We don't do based on intuition and all. Okay, that is why x and y variable, we need to have x train, y, x test, x y train, y test. This is the main logic. Okay, and here how well you are training your model, and there are other factors, collecting right data as per the problem statement, cleaning it properly, pre-processing, EDA, everything. But here magic lies here. If you are training well, how many deep layers you train, you will add those many zeros after your salary. So training is so crucial. Okay, if you train 100 layers of data, I mean to say deep learning, like layers, okay, neural network layers. So if you train that, so you add 100 zeros after one to your salary. That is very powerful, guys. There is no limit to earn money. Okay, but do you understand these things deeply at a meta level? That is very important. Okay, so x train shape, we see x train shape, we see x test shape, we see y train shape, we see y test shape. So this is how the output is here. So it depends on what is how you have defined x, y, and test, what is the range, all those things, and it will show you according to that. Then loading model using linear regression. We are using linear regression. You can use any model as per your data characters, problem, statement, and what you want to achieve. Okay, we have used linear regression because we are studying linear regression here. So model equal to linear regression. Okay, then we go to step 8, training the model. Here we train on X and Y, train. So train means training. Okay, test, when you see X test, Y test, X train, Y train. Y train means training, X variable, Y variable, X variable, you have to train that data set because we have defined X what it is, right? So that Y and X will be trained. Okay, then tested, whatever we have defined earlier, that would be tested. Okay, it's very simple. And model, we have used linear regression step. Then we are predicting the results using the trained model. Now model is trained. Okay, and then we are predicting based on Y predict equal to model dot predict. Always for predicting we have to use this syntax, Y predict equal to model dot predict. So because we have defined model, it will predict according to that. So it will depend on your model, which model you have used. It will predict that X test. Okay, so what is that? So then we have in array, this is the result. Okay, then we have average score of 98. Okay, that is the score we got for this model. Okay, so this is, then we have to print the score, and that is our score equal to this. Okay, the accuracy for the model. Okay, so this is a pretty good score. 98, after 90 it is considered a good score for your model, right guys? So this is a pretty good score. And then we print the output, like the then we predict the output of single sample using trained model, and then we have this output, right? Is it done? Yeah. So then we predict that
Yes,
output, that is 140.15, which is based on the sample, single sample guys, 50/20. We have taken that sample size. And so do we have, yeah, that's it.
that's it.
Yeah. Okay, great. So keep learning deeply, guys, with long-term objective function, and keep learning deeply at a meta level, deep meta level. Understand concepts properly. Huh? So, it's the excellence is not into the outputs and using tools and application. Excellence lies in each and everything. How well you paying attention to each and every detail of the concept and absorbing it, digesting it, and applying. Then excellence will come. Okay. Still, there would be uncertainty, guys. Huh? So be very, very, very prepared and skilled. Data scientists, AIML engineers, and AI researchers, scientists. So we want to create that breed for future. So keep learning deeply. Thanks.
Yeah, as always, like guys, just as sir is mentioning, please make sure you guys have a proper understanding. If you guys doesn't understand anything, okay, just come here, just ping in the group, like sorry, ping in the comment section. We will take up and we will just make it up. And one more thing, guys, you guys can see, right? There is only two lines of code. Okay, you just load the model, just predict it, and then go train it, and then predict it. So that's the reason we are just insisting that you guys need to have a theoretical knowledge of it. Okay, so as I'm mentioning again and again, this thing, who are not a data scientist can do it. Okay, only thing which is differ from all of us is that we know the black box behind it. Okay, so hope you guys have enjoyed this session. I am just enjoying this coding session very lot. Okay, when compared to theory, but like both are very important. But like this coding session will give you an idea of what the theory is. Okay, you will get to know what is the magic going to happen in the coding. Okay, we're going to continue this theory coding session until unless we're going to end it with the entire session. Okay, so hope you guys are enjoying. We are enjoying a lot. So that's it for today's session. So we have
So,
completed the coding part of multiple linear regression. Hope you guys have understand everything. If you guys have any doubts, just let us know. Okay. So yeah, guys, we will pass here and we will continue in the next
Yeah.
section.
So
Yeah.
guys,
Thank
see,
you,
I'll
guys.
tell you, when you look at information, each and everything is idea. So when you don't understand idea conceptually, what is theory? Okay. A lot of people say there is theory, there is practical. There was an age when people will focus on theory only. And there was now after 21st century, people started saying practical, practical, you have to do apply and all. So I'll say both are extremes. They are outliers for me. I'll tell you why. Because theory, until unless you don't understand the concept is what? Idea. You don't understand properly. How can you apply that? And you will make mistakes and errors. What I'll say is right combination of theory, understanding the concepts. I'm not saying you understand a lot of things. Just understand the actual concepts of the any idea, any concept, understand that deeply, and then application. And balance of it is the future, guys. Not extremes of it. There was a age like theory, people are just mugging the information, but then there is a oh, practical. Both are so crucial, guys. You can't do practical until you understand deeply theory. You can't if you don't do that, then you will not be able to apply. So then there is no use. Half it would be half cooked knowledge. That is not going to help you. So balance of both, understanding each and every concept and applying according to that, that's what it is. Okay, so do that deeply, go to deep meta level, understand concept and apply, absorb the information, digest the information and apply. Keep doing it with persistency, consistency and perseverance with long-term vision for your career, and keep learning. Thanks.
Yeah, guys. Thank you all. We will all meet in the next session. Until then, bye, guys. Take care. We will all meet in the next session. Bye, guys.